Hello, my name is Satoshi Takahama, and I'm happy to represent my partners, Ann Dillner and Thanos Nenes, in communicating the main ideas behind our SDSC project, cost-effective chemical speciation monitoring of particulate matter air pollution. Inhalation of atmospheric particles are associated with impaired neurological development and heart and lung disease, causing 7 million premature deaths worldwide. These particles are also critical for cloud formation and have profound influences on precipitation patterns and the energy budget of the Earth. For regulatory and scientific monitoring, mass concentrations of particles are recorded by pulling air through filters for collection and weighing them on a sensitive balance. However, atmospheric particles are complex mixtures of inorganic salts, organic matter, soot, mineral dust, and other substances, and understanding their composition at each location is necessary to identify source contributions, possible impacts. My partner, Ann Dillner, and I have demonstrated over the last decade that the same filters collected in these networks can be passed through an infrared spectrometer to rapidly acquire its infrared signature, which arises from a multitude of vibrations of molecular structures present in the sample. During this time, we've been able to show that quantitative information regarding chemical composition and source contributions can be extracted from these spectra using simple models, but each problem to be solved has its own model. So the main idea with this SDSC project is to build an open, collaborative platform and introduce modern machine learning techniques that can reduce the number and generalizability of these models by making use of common representations that can be learned from the data. This task is made possible by the more than 100,000 samples we've populated in our reference database with co-located chemical measurements in the field, together with laboratory standards that provide information on the chemical species that give rise to the observed infrared spectrum. We expect that the results of this project will lead to expansion in capabilities of monitoring networks and research groups worldwide to cost-effectively estimate particle composition, identify key sources, and support effective pollution interventions, as well as provide insight into atmospheric processes that are necessary to improve our capability for photochemical transport modeling. Thanks very much for your attention.